So in Scratch, the way that we controlled the character is using, where is it? These if key right arrow pressed, move 10 steps. And it's inside of this forever block. So this is basically what we're going to recreate right now using JavaScript and P5. The key differences are the forever part is now handled by the draw function. So the draw function in P5 is sort of like the same thing as the forever block. It's always drawing. Everything else is pretty much the same, except we're going to be writing out the code in JavaScript rather than using the blocks. And we're going to, again, be using the variables that we created. So the move 10 steps is changing the X and Y position, and that's built into Scratch, but we're going to be writing that on our own. We're also going to be using an if statement, just like we did in Scratch, to determine if the player is pressing the key that corresponds with the movement that we want. And so we'll look at how to do that in JavaScript. And we're going to do a couple examples of those things before we add it into our code. So I'm going to make a copy of this example first. This is what we have right now, where we can just move our character with the mouse, but now we want to add the keyboard input. So I'm going to go ahead and duplicate this sketch, and I'm going to call this events, keyboard input, and character movement. It's kind of a long name, but that's okay. So I'll change the comment up here. We'll say using keyboard events to move character. And what we're going to do is we're going to use those X and Y variables that we created, but now we're going to use a couple of keyboard events to change those values. So instead of just mapping them to the mouse or to a specific value, we're going to change those values using keyboard inputs. There's two concepts that we need to review or learn before that'll work. So I'm going to do these in a separate editor window just to use something that's a little bit simpler to get started. The first thing that we need to learn is something called variable scope. So I'm going to rename this variable scope example. And I'll just save that and add it to our collection. And for this, I'm not going to use any P5 drawing. I'm just going to get rid of all this stuff for a second, and we're just going to look at some basic code. In our sketch where we created our variables, we had, let's imagine that I have a function. I'm going to turn off the hinter for a second. So let's imagine that I have a function called, let's just call it example. And let's say in this example function, I say let x equal 1. And I'll say let y equal 2. So I have a couple of variables, and I can use those variables to do different things. I can say console.log x and y, and that'll just print out those variables for me if I run the function. So let's run the function down here. So there we see 1 and 2. So this function has run. We've declared the variables, we've given them values, and then we logged those values out to the console. So all of that works perfectly well. The problem is if we want to use these variables anywhere else. So let's imagine that after I run this code, I want to do something with x. And so let's console.log. Let's say I want to add to x. So I'm going to say x plus 1. And if I run this code, I get this reference error. X is not defined. So the reason that I get that error is because even though I created x here, it doesn't exist outside of the function. So this is called function scope or block scope. Yeah. Yeah, so we're going to have to move it somewhere else. But we can do it in different ways. But yeah, we're going to declare it first. So this is called function scope or block scope. If we declare a variable, it only exists inside the function. Okay, so I'm going to comment that out. This gets a reference error. What? You can. Yeah, you can do that. We're just going to go over the basic example for now, but there actually are examples next week where we'll do something similar to that. Okay, so if we want to use a variable inside a function and still have it available to us in the rest of our code, we need to declare it outside of the function. So just like Wesley was saying, we can say let x equals 1. We can say let y equals 2. And so now if I log these, I can say x and y. And I won't get an error there. So you see, let's give them different numbers actually, just so we know that they're working. So we have our 1, 2 up here, and then we have our 3, 4 down here. But notice if I make a new function, and I'll just call this scope. Now if I console.log x and y, it's going to reference these global values. Let's call this good scope. So now it's going to say, let's run good scope. So we get 1 and 2, and then we get 3 and 4. So our bad scope example, let's say function bad scope example. This actually isn't bad. This is just another thing that will happen. So if I say let x equals 5, and then I console.log x and y, and let's not call this bad. Let's just call this another scope. And I run that code. Notice that x changes to 5. Y is still 4. So if we declare a variable inside the function, it overwrites or it takes the place of the global variable. So we have to be careful about how we name our variables and where we declare and use them, because sometimes you might have, in this code, we have multiple statements that say let x equal different numbers, and we don't have any errors. Our code runs, perfectly fine. So we have to be very careful about what we name our variables and where we use them. For now, we're going to keep things pretty simple and use just these basic global variables. But in general, we kind of want to avoid global variables. Global variables are variables that exist outside of a function. Okay. So that's one thing that we're going to have to do to move our character. The other thing that we're going to do is use some key commands. I'm going to go over a basic or keyboard input. I'm going to go over a couple examples of keyboard input, and then we're going to put it all together. Okay, so this one I am going to use setup and draw. I'm going to use my drawing functions to give some examples of keyboard input. So I'm going to call this keyboard input examples by Owen on November 4th. Okay, so in our reference, if we leave square and go back to our reference, there's a whole section on events. Let's see if we can find it. Environment. Where's events? Math. Okay. Maybe oh, here we go. Events. Okay. So events describe things that interact with our program from, the real world. So that can be things like you can see acceleration X, Y, and Z. So that's like when you're moving your phone, there's a little sensor in there that can sense how fast it's moving. So we can use that. There's a bunch of other events related to that, like device shaken, device turned, acceleration, rotation. So these are all events that are kind of related to a mobile phone. Then we have keyboard events. So these are all events that relate to the keyboard, so pressing keys on the keyboard. And we have mouse events. There's a bunch of different mouse events. And touch events, if you touch a touchscreen. So we're going to work with keyboard events today. We're just going to add 2 keyboard presses to move our character back and forth. There are 2 basic types of events. And you can see some of these events don't have parentheses. So all of these events are just pieces of data. They're like variables. So the key is just a value that describes the key. So it might be like, A or B. The key code is a number that describes the key. So all of the keys have specific codes that they're associated with. So like, for example, 65 equals A. And these are the ASCII values. 66 equals B. And then key is pressed just tells us whether or not a key is pressed at all. So this could be true or false. These are all what are called like continuous events. These values always exist. So for example, when you're using the keyboard, let's imagine that this is time. And this is our program starts at 0 and this is infinity. If we take the key as an example, the key will always have a value. If you press the A key, that's a pretty bad A. The key is going to be A until we press something else. So let's say we press the A key at the beginning, and then here we press the B key. The B key is going to keep, the key value will just stay B for as long as that's the last key that we've pressed. That's a continuous event. So it's always happening. These little blips are called discrete events. That means it happens at one frame in time. So discrete, it means it has like one specific frame where it happens. Our events that have little parentheses are functions, and they handle these discrete events. So when I press a key, I'm going to launch the key press function. So when I press the A key right here, the key press function will react to that. When I release the key, maybe that happens here, that will trigger key release. So when I press down and then release, those are 2 separate events. Then when I press the B key, that's another key pressed and key released. So most of the functions, actually not all the functions, this one isn't, most of the functions are discrete events. The function that we're actually going to use is this one, key is down. Key is down is going to return a value. So it's just going to tell us if a key is down. So the key is down is always going to be either true or false. So if we say, is the key down A, it's going to be true as when we're holding it down, and then it's going to be false when we're not holding it. So there's a bunch of different events, and they all act sort of differently. The one that we're going to work with today is this one, key is down, because it's very simple. And it's continuous, and we want to be measuring it continuously to see if we should be moving our player. So key is down will tell us true if there's a key that's down and false if not. And we can check for specific keys. So we can see left arrow or up arrow, and then we can check the key codes. So if we go to the key code values, we can test for different key codes. There's a list of them somewhere. Oh yeah, here. So this links. This is in the reference. It links to this keycode.info website, and this is just an easy way to find out which keys correspond to which values. So if I hit the A key, we can see that the value is 65, and then there's other values that are associated with it. If I hit Shift A, it's still 65, but it'll show us that the Shift key is being held down. And the left arrow is 37, right arrow is 39. But P5 has some built-in constant variables that we can use for that. So let's just stick with those because it'll be slightly easier to read. So we've got left arrow, and we'll use right arrow. Okay. So what I'm going to do here is I'm just going to give a very simple example. And we're going to also use what's called a conditional statement. So this is like the if blocks that we used in Scratch. We're testing for a condition, which is if the key is pressed. So in JavaScript, we're going to check if the key is pressed, and if it is, for this simple example, we'll just change the background color. So we're going to say if. Any conditional statement starts with if, just like our if block. And then in parentheses, we put the condition. And then in a little code block, we put the code that we want to happen if the condition is true. So this looks very similar to a function. We have function, we have a name for the function, and then we have a parentheses and a code block. So our code uses a lot of the same patterns, but in different instances, or in different cases. So just like our if block in Scratch, we have if, then where this like little diamond shape is, that's our parentheses, that's our condition. And then the code block is the inside of that block. So the condition we want to look for is key down, or key is down, sorry, which we see here in the reference. So we just type in key is down. And you can see it highlights blue because it recognizes that it's part of the P5 library. And then that gets its own parentheses. So we have the parentheses inside the parentheses. This is a little bit similar to P5, where we have like the little diamond inside of the other block. But when we're just writing our code, or text-based code, sometimes we have parentheses within our parentheses. So then for the key, let's start with the left arrow. And sometimes your conditions will look like different things. We'll see examples of other conditions in future lessons. So if the key is down left arrow, if this whole thing is true, then let's change the background color. So I'm going to go into my code block and hit enter. And so anything that happens in between these two curly brackets will only happen if the left arrow is pressed. So I'm going to draw the background again, but this time I'm going to make it green. Okay, so we see the gray background, and if I hit the left arrow, then it turns green. We can write as much code as we want to in this block, but for this example, let's just stick with that. So let's do another example. Let's say if key is down, whoops, right arrow. Let's do background is pink. Okay, so now I have green and I have pink. So one thing that we do have to be careful about is, well, actually, we don't really have to with our character, but for now, what do you think will happen if I am pressing both the left and the right arrow keys at the same time?
Cancels each other.
So what would happen if they canceled each other? Nothing would happen? Okay, any other guesses? What color do you think the background is going to be? What?
Like mixes.
Okay, it could mix. Any other guesses? Yeah. Okay, my flash green and pink.
And that's like if you do it like this.
Yeah. So if you hit them both, but what if I'm holding them both down? Yeah. Okay. Ahmed thinks it'll only show the pink.
Well, well,
It'll show whichever key press it detected first.
Okay. Whichever key press it
last,
detected
actually.
last.
I'm thinking it might like be turned green because it might prioritize that coding since it's above the pink.
Okay, so you think the opposite of what Ahmed thinks.
I think the system would crash. The computer.
Yeah.
Okay, so let's see what happens. So I'm running the sketch, and I'm holding both keys.
Oh. Pink.
Okay, so now I'm gonna hold left and then right, but I'm holding both. Okay, now I'm gonna hold right and then left.
Always pink, yeah.
Okay, so it's always pink. So when we're reading code, we go from the top to the bottom. So Ahmed is right. The thing that happens second is going to cover up the thing that happened before. The other thing to keep in mind, Robbie's idea was good, that it's going to prioritize which one happens first. But that would happen if we were using the key variable rather than key is down. But because we're just asking if key is down, if both keys are down, then both of these statements are true. So the left arrow is down, so it's going to draw the green. The right arrow is also down, so then it also draws the pink. So the order that we do it in kind of matters, and it's actually not going to matter necessarily depending on what you want with your game. But it might matter when you're designing the character movement, what order we put the events in or how we deal with the order of the events. Okay. All right, so let's put all of this into our game. I'm just going to name this keyboard input example and throw this into our collection. Okay. So, what I want to do is add some keyboard input. So I'm going to say if key, let's turn off my complete. If key is down, right arrow. So if I'm hitting the arrow key down, what I want is for my X value to go to the right, to move the character to the right. So I'm going to take X, and then I'm going to add, let's just add 5, just to start. So what I'm doing here, this is a little bit of a complicated statement, but what I'm saying is I want to take the value of X, and I want to add 5 to it. So I'm saying X is going to be equal to X plus 5. So if X is 200, and I'm going to get rid of these mouses for a second. So if X starts at 200 and Y starts at 200, if I take 200 and I add 5, I get 205, and then I assign that back to X so that X continues to be 205. If I just said X plus 5, it would just say, okay, X plus 5, that's 205, that's great, but it doesn't actually assign it back to the variable, so it doesn't do anything. So we need to say X equals X plus 5, and this is the same thing in Scratch if we look at variables. When we say change animation by, or change variable by, this also happens in Motion where we have change X by 10. So instead of just changing X to 10, we're changing X by 10, we're adding 10. Okay, so this looks good, but it's not gonna work. So look what happens when I hit the arrow key. He moves a little bit, but then he goes back. He gets reset. And that's because of our scope example. So remember that draw is constantly drawing the whole time. our program is running. And so every time we get back to the beginning of the draw function, x is being set back to 200. So even though I'm adding 5 here, when we go back to the beginning, x becomes 200 again. And so what Wesley was describing earlier is correct. We need to move our variables out of the function scope. So we just declare the variables, but then they change inside the function. So we're going to just cut, and we're going to move these guys up here and paste. And this is the global scope. So now I can still use x. X still exists. But now x can change because we only declare it once and assign the value once. So now when I keep hitting x, the character keeps moving. I'm going to turn off the mouse press down here for a second. Okay, so now I'm just going to implement the left arrow. So this is exactly the same. If key is down, left arrow. And I'm just going to say the opposite. X equals x minus 5. So now I can move left and right on the canvas. And if I hold both buttons, it's both adding and subtracting 5. So it actually just stays in the same place because they do cancel each other out. So that doesn't necessarily happen, but in this case it does because of the math behind it. Okay. So that's it for this example. I just want to be able to move my character back and forth. We'll start to add a little bit more to it next week, but for now we just want to make sure that our variables work and that we can move the character left and right. If you want your character to move up and down, you can probably figure that out. I'm not going to go over that right now. But your character should at least go left and right for this week. Okay, I'm going to save this example and add it to our collection. And so hopefully you've already got your variables implemented, so this will be easy to add in. Let me know if you need help with that. I can go over it. But you should have the character moving back and forth by the end of today. That's pretty much it. Remember, and if you want to update the character or change the way it looks, feel free to do that. It doesn't have to look exactly the same as what you had before. If you need to simplify it or you want to add other features to it, that's fine. We are eventually going to replace the character with animated sprite art. But for now, I just want to focus on learning the programming. So for this week, we're just adding the variables. So when you post your project, it may look basically the same. That's fine. Just include a link to the code. And remember to make a copy. So when you add new features, just remember to go to File and Duplicate so that you're not replacing the code from your previous project. If you already did that, it's not the end of the world, but that's just a good practice to have to make new versions of things. All right, I'll stop the video.